Hello everyone, myself Aishwarya Soni. Today I'm gonna explain you about registration in IT, encapsulation and tunneling. Before we move on to the topic, I would like to give a brief introduction about why we require registration. As we all know that whenever a mobile node moves from one location to another, its care of address changes. Now, the new care of address should be registered with the home agent for the correct delivery of packet. Therefore, this is the purpose of registration. Now, each mobile node has a unique can be uniquely identified by NAI, that is Network Access Identifier. Uh, for a mobile node, it is not always necessary to have a home address. Since NAI does the authentication and authorization of the mobile node, it can be easily connected to a foreign domain, and whenever it needs to get the home address, the MN can set the field of NA extension to 0 to get the home address. Now the requests of NI are served by AAA server. AAA server is authentication, authorization, and accounting. It is a server program that handles the request uh, for accessing to any of the computer resource or any services. The server typically interacts with the network access and gateway containing the user information. Now, the two types of registrations are first via foreign agent. In this, if the COA is at the foreign agent, the MN sends the request to MN sends the foreign request. MN sends the request to foreign agent, and the foreign agent sends the request back to home agent. As the home agent gets the request, it establishes or sets up the mobility binding. Binding is a tuplet which contains the home address, care of address, and lifetime. Lifetime is the validity of that registration. If the registration is not done in that particular time limit, it will be expired. So MN needs to register before the before the lifetime gets expired. Now, as soon as the home agent does finishes up with the mobility binding, then it sends a registration reply to foreign agent, and the foreign agent sends the reply to the mobile node for acknowledging that the registration has been done. The second type is when the COA is co-located. It is simpler as compared to the first one. In this process, here MN directly sends the registration request to home agent, and home agent directly sends to the mobile node. So this is the way how registration works. Now, uh, moving on to the registration request fields. For the registration request, the type one is need to be set for registration. There is a S bit, which there is a S bit which specifies that the home agent wants to retain the prior mobility binding. The B bit, which says that the broadcast messages sent by the home address, sent by the mobile node, sent by the home addresses should be all. MN also wants to receive it. D is the decapsulation bit. If MN uses a co-located COA, it takes care of the decapsulation at tunnel endpoint. M M is for the minimal encapsulation. G is generic routing encapsulation. T reverse tunneling, and R and X bits are set to be 0. Now, here we have a identification number. It is a 64-bit number, and this is used when when uh, uh, a request is need to be processed, and for matching the request and reply numbers, so that there should not be any mismatch between this process, and therefore it is used. Now for the reply fields, now the type is need to be set to 3. This shows that it is a registration reply. My second topic is tunneling. Tunneling establishes a virtual pipe for data packets. between a tunnel entry point and a tunnel endpoint. Tunneling, it is a process by which data can be transferred, and it is achieved through encapsulation. When a tunnel header is between a COA and foreign agent, then the tunnel and start point, the entry point would be at home agent, and the end point will be at foreign agent. Second, when a tunnel header is co-located using co-located COA, then home agent will be the entry point, and MN will be the end point. Encapsulation. Encapsulation is putting a data header as data for another packet is encapsulation. It is a mechanism of taking a packet consisting of packet header and data, putting it into the data packet of new packet, data part of the new packet. Um, uh, and the part of another packet, and taking out that data part from another packet is decapsulation. Three types of encapsulations in mobile IP. First is IP and IP encapsulation. In IP and IP encapsulation, it takes the home agent takes the original packet with the MNS destination, put it into the data part of the new packet, and it is routed to the COA. This is IP and IP encapsulation. As we can see here, over here, that many of the fields are repeated. Therefore, a lot of redundancy is there in this encapsulation. Therefore, we have to reduce these drawbacks. We have jumped to minimal encapsulation. uh, Here we can see the inner header packets and the outer header packets are fields are repeated. So to reduce this, we have uh, switched to minimal encapsulation. Now, in minimal encapsulation, the protocol field is set to 55. Rest all the informations are almost same, and the repeated fields are neglected, are not used. Whatever changes are there are reflected in the inner header, and whenever the information of original header is included, the S bit is set to 1. These are the differences. An outer IP header is inserted between the datagram existing IP header, and the protocol number for IP and IP is 4. Generic routing encapsulation. In generic routing encapsulation, we have been using this since the IP and minimal encapsulation. There is a drawback that both of them can transfer the packet in only one protocol. So in generic routing, we can send a packet from one protocol into a different protocol or another protocol. So for this, we support a packet of one protocol to be the data part of a packet of another protocol. For this, we use a GRE header, and it is assigned to the original packet, and that comprises of the data part of new header, and that is sent to the COA. So using this header, we can send a data from one protocol to another protocol. So this gives an overview of registration, tunneling, and encapsulation. Thank you.